secant and cosecant, a lot of times I like to just remind you of how you need to do like a secant and cosecant on a calculator. So if you're doing a secant, now this is in radians. The first thing I'm going to do on my calculator, so I need to make sure I'm in radian mode. Well, remember the secant is 1 over the cosine. That's the reciprocal of the cosine. So if you're going to do the secant of 0.42, you've got to put it in your calculator that way. Your calculators typically have sine, cosine, and tangent. So what I do on this is I just go 1 divided by cosine of 0.42, and then I'll round that off to 4 decimals. So we've probably done a little bit of this before, but I just want to review this. So this is 1.0952 if you did that. How would you do a cosecant? 1 over sine, right. So that's 1 over sine of 3.66. Now you want to be sure that you're in radian mode on this. So we go 1 over sine of 3.66, and then we'll round that off like that. So this one would end up being, the cosecant is negative 2.0182 like that, all right? And I'll just do the other two real quick. It only takes a second to do that. So the secant of 0.31, you do 1 over cosine 0.31. Then we'll just round that to 4, so that's going to be 1.0501 is how that would round actually. And then the cosecant, I'll go 1 divided by sine of 5.24 radians, and that'll give me this value like this. Okay, so that's kind of what happens on your, when you're doing like a secant and cosecant, you have to do it on your calculator like that since you don't have those buttons. So what I'm going to do is I'm going to start by taking you through a graph of the cosecant and kind of putting the basic one together for you here tonight. So whenever we do a graph of a cosecant, you need to graph the sine first because the cosecant's the reciprocal of the sine. So what you want to do is you want to be able to do this real fast. From the unit circle, all I'm doing on the sine again is I'm just looking at the y values. You want to get that memorized or be able to figure out that really fast. So you'd have at 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. And it goes like this. And then this would just repeat itself. So that would be 0, 1, 0, negative 1 like that. Okay, so that's what we've already learned. That's how the basic sine wave is going to go. All right. Now the cosecant is equal to 1 over the sine. So what I'm going to have you do here is we're just going to do reciprocal. So we just do 1 over 0. When you do 1 over 0, you get something that's undefined. That's going to give you what we call a vertical asymptote that we've learned about. You do the next one, you do 1 over 1, that gives 1. And then 1 over 0, you get undefined. So what you're going to find is everywhere the sine is 0, the cosecant is undefined, so your graph is going to have a bunch of vertical asymptotes on it like that. Okay, everywhere else, just do the reciprocal of 1, it's itself. The reciprocal of negative 1 is negative 1, and so forth like that. So what I've done is I've done the reciprocals to put that together then. Okay, all right, everybody with me there? Okay, now we're going to go to the next page. We'll put together the graph on that, and I'll kind of show you basically how this goes. I'm going to take a little snapshot of the table of values so I can refer to that as I'm going through the graph. So on the next page, you want to go ahead and just draw out a XY axis, and I'll put the table right over here. Okay, so let's go ahead and just draw an XY axis. And then what we're going to do with this one basically is we're going to look at the period being 2 pi. All right, we're going to go by the same increments that we have on that table of values, because when we do the graph of sine x, the period's 2 pi. That's the standard. Okay, so we're going to go ahead and just do your x-axis like this. Go ahead and write pi over 2, then pi, and then 3 pi over 2, and then 2 pi, just like the table of values that we did on the previous page has. And then go ahead and do the same thing with the negative. So you want to have negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi like that. Okay, and then let's go up to about like maybe 4 or something like that. I want you to go a little bit beyond 1. There's a reason for that. Okay, so that's, you always want to get everything labeled when you're doing a trig graph. And what we'll do with this is basically everywhere the sine was 0. We're going to go ahead and graph the sine in red first of all. So go ahead and just sketch in your sine wave like we've learned how to do. And again, you want to get that memorized as fast as possible so you'll be able to do your graphs pretty quickly and efficiently. So that's your basic sine wave cycling through those 2 points, and that is 2 cycles. That's 2 periods right there. Okay. Now what happens on the cosecant is everywhere the sine is 0, I'm just highlighting where the sine is 0, you're going to have a vertical asymptote. So you want to go ahead and draw vertical asymptotes right through those values there. Wherever the sine is 0, the cosecant's undefined since it's the reciprocal. So you want to go ahead and just kind of sketch in those asymptotes like this. Okay, then I'll show you kind of how this goes, and I'll try to explain with the work of the calculator why this works the way it does then. So what happens is when you do a graph of a cosecant, when you find the maximum, you just put a U shape on top, and then it approaches the vertical asymptotes like we've learned. It's not going to touch the asymptotes, it's just going to approach them. When you find the minimum, the U shape is just going to go downward towards the asymptote like that, and it's going to do that shape over and over again like this. So basically what you would have is it looks like a parabola, but it's not. It's just kind of a U shape that's between those 2 asymptotes like that. So that would be what the graph of a cosecant looks like. Now let me show you something on here just to give you an idea here. So like for instance, if I take a number, if I do like the cosecant, well, I got to do 1 over sine to do the cosecant. If I took a number barely bigger than 0, okay, like if I did 0.0001 radians, look what happens. You get a real big number. So what this is saying is if you're barely to the right of 0, the cosecant takes off to infinity. Okay? If I did this, if I did 1 divided by sine of negative 0.001, just get a number that's real close to 0 on the other side, then it becomes a very small negative number. So that's saying if you're barely to the left of 0, the graph goes down like that. Okay, so that's what happens, is that's why it approaches infinity and negative infinity. That's how it behaves. Okay, so that's how the graph of a cosecant would look, and all you got to do is really sketch the sine, locate the asymptotes, and sketch the rest. That's good enough. That's accurate enough. Okay, so a couple of observations I want to make on this now is when you're working with a secant here, or a cosecant here, the domain would be everywhere except there's an asymptote. So what I want to do on this is let's just write down where the vertical asymptotes are, what we found. So let's see, we found negative 2 pi, pi, 0 pi. I'm going to write that as negative 1 pi, 0 pi, 1 pi, 2 pi, and so forth like that. Well, it would go 3 pi, and then it would go 4 pi, and it would go forever, right? So what you got to do, if you're going to do a domain, you have to tell me where it's not equal to. So you have to write this in terms of a formula. So what's happening is the asymptotes always occur at pi, but what kind of number? 1, 2, 3, 4, 0, negative 1. What do you call those numbers? Integers. You call them integers. So the way you have to write this is like this. Okay, just think of this as k pi. Okay, so that number in front of pi is an integer. So what we do when we write the domain, we write it like this. We just say set of x such that x is not equal to k pi, and we say k is an integer. Okay, so you gotta write these things out as formulas, and you'll pretty much always be able to see a pattern if you just write them out. Okay, so that's how you would write your domain. There isn't any other way to write it. If you did interval notation, you'd have a bunch of intervals, an infinite number of intervals, so you just write it that way. Okay, all right. Now, if you look at the orange graph, this orange graph does not have a minimum. It goes down forever. It does not have a maximum since it goes up forever. So you have no minimum and you have no maximum. That's totally different than the sine and cosine were. Okay. The range on this, just think about the range. The range would be like this. You can write it 2 ways. You could say set of y, and you could say y is less than or equal to negative 1, or y is greater than or equal to positive 1. That's one way to write that. That's just saying the y values are 1 and bigger, and -1 and smaller. The gap between that is made up by the sine. You could also write this in interval notation as -∞, -1 with a bracket, union 1, infinity like that. Okay, so that's how that goes. Okay, the period is 2 pi, and just let me kind of show you what that is. So basically, you really, in a sense, have 5 key points. It's kind of like this. You have an asymptote, you have that minimum, you have another asymptote, you have this maximum, and then you have that asymptote. So it's like 1, 2, 3, 4, 5. That distance from 0 to 2 pi is 1 period. So it's just the 3 asymptotes and the 2 U-shapes. That's what defines the period on a cosecant then, okay? The amplitude is you don't have one, all right? And the reason you don't is because the amplitude is really defined to be 1/2 the max minus the min. That's it. Now, you're used to seeing like the number in front of the sine and cosines and amplitude. That's what we worked on today. But technically, what an amplitude is it's the max and minimum, half the distance between. Since this doesn't have a max and it doesn't have a min, then you couldn't calculate it out. Okay, so anytime you don't have a max and min, you're not going to have an amplitude. Okay, now the equations of the vertical asymptotes go like this. So again, we've already kind of done this. The vertical asymptotes just occurred at 1 pi, 2 pi, and so forth, like that. So you would just say x is equal to, and vertical lines are always x equals. You got to know that. And then you would just say k pi, and then you would say k is an integer. Now, if you get tired of writing k as an integer, just write it this way. Put this e, which is called epsilon, and put a z with a double bar. So if you see me write this, that's the way a mathematician usually writes that you're a member of the integers. Epsilon means it's the member of the set of integers. So you can always write that way if you want to. I'll probably do that pretty much from here on out. Okay, so that's how that goes. The other thing that you can do is with this is, in general, the equations of the asymptotes. The reason I'm giving you this formula is most of the time if you're trying to figure out what the asymptotes are, you just write them out and see if you see a pattern and try to write it as a formula. If you don't see a pattern, then do this. And I'll show you how it would work on this. What you'd do is just say x equals and pick an asymptote. It doesn't matter which asymptote you pick. So you could pick 0 if you wanted to. Okay, so I just say x is equal to 0 plus 1/2 the period. The period on this is 2 pi times k, with k being an integer. So you can always use this formula, and if you work this out, that would cross out. That would give you x equals pi k, with k being an integer. That's what we got anyway. Okay, so you can do that if you need to. What I like students to try to do if I'm asking you to write the equations of a vertical asymptote is to list them and see yourself if you can find a formula. You ought to always try that first, and if you can't, go to that formula, okay? And the thing that I want you to try to understand about this formula is this. The reason why it's half the period k is because what happens halfway in the middle of a period is you have an asymptote, right? So you have your first asymptote, then the period, but halfway in the middle is another one. So that's why we say plus half the period k gives the next asymptote. Okay, that's the idea behind that. That's how I remember that. Okay, let's move on. Let's do the secant. Let's kind of take care of the basic ones first of all here. Okay, so when we do a secant, we're going to work with the cosine. It looks like these things are wrong. This needs to say y equals cosine of x, and then this needs to say y equals secant of x. So you need to change that, because if we graph a secant, we got to graph a cosine. All right? So the cosine is all of the x values on the unit circle. So we're just going to fill these out. The cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0, and so forth like that. And so you can just move this over here and then just rewrite these. 1, 0, -1, 0 like that. Okay? So that's how the basic cosine goes. Now, when you do a secant, we're going to do exactly the same thing as what we did on the previous problem. The secant is just equal to 1 over the cosine of x. So you're going to take the value of the cosine and take its reciprocal. So you'd have 1 over 1 is 1. 1 over 0 would be undefined. It's a vertical asymptote. 1 over -1 is -1, and so forth. So everywhere the cosine is 0, you have a vertical asymptote. And then the rest of those reciprocals you just do in your head. Okay? So that's how the table of values is going to go then. All right? Okay. Everybody understand what I just did there? Okay. Okay. Do the that's all comes from the unit circle. Okay. And then the secant's the reciprocal. Okay. Let's go to the next page and then, or hold on, let's do a graph underneath here. Let's go ahead and do the graph just at the bottom of the page here. Okay. So just go ahead and start by drawing yourself out an X and Y axis. Okay. So let's just write that out and get everything kind of labeled like this. Okay, and then we're going to label this kind of the same way. We're going to have pi over 2, then pi, then 3 pi over 2, and then 2 pi, just following the table of values. And then negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi like that. And then let's go ahead and just make the y's go up to like 4, because the graph's going to look real similar to the previous one we just did. Okay, like that. So if you were going to construct a graph of the secant, you would go like this. The first thing you do is you graph the cosine. Now just remember the cosine starts at 0, 1. And then it cycles through these points. Get this memorized so you can quickly draw out a cosine graph anytime you need to. Okay, then I'll just kind of dash that in. That's the graph of the cosine. Okay, then we're going to do this the same way. The graph's going to look almost the same anyway. So everywhere the cosine is 0, these places where I'm highlighting, you want to put a vertical asymptote through those points. So go ahead and put your vertical asymptotes on there. And then the rest of it, you just sketch in. Okay, you sketch in those U shapes, so I'll show you how that goes. So the graph is almost the same, except it's really a phase shift of the cosecant that we just did. So from here, what you want to do is just, when you see the minimum, you just make the U shape go down towards the asymptotes. When you see a maximum, you make it go up. Okay, like that. And even this part right here would be like half of a U shape there, and then half of one right there. So that's what the graph of the secant looks like, and it's just based on the cosine's graph. Okay, everything from there is going to be pretty similar. Okay, all right, any questions about how I did that or how that works? Okay, now a couple of observations on this one now that I want to go through. Okay, now the domain is going to be everywhere except where you have an asymptote. So let's do this. Let's write down where all of the vertical asymptotes are. Okay, the vertical asymptotes are at -3 pi over 2, -1 pi over 2, +1 pi over 2, and 3 pi over 2. Okay? What do you think comes after 3 pi over 2? Is there a pattern? What'd you say? Yeah, 5 pi over 2. Good. Okay. So what's happening? What's the deal with the numerator? What kind of number is it? It's an odd number. It's an odd integer. Okay, so it just goes 1, 3, 5, 7, and so forth like that. But you always have the pi and you always have the over 2. So if you look at this, see, you always have pi over 2, but this number that's in front of pi is going to be the k. So you would write this as k pi over 2, with k being an odd integer this time. So the domain you have to write like this. You have to say set of x, and x is not equal to k pi over 2. And I don't have a symbol for odd integer. We're just going to say k is an odd integer. Okay, so that's what the domain is. It all depends on where the asymptotes are. And typically the patterns are pretty easy to see. They're usually they can be even integers, odd integers, pi over 2. They're usually pretty easy to see. Okay, and this one does not have has no minimum, and it has no maximum. So if you look at the orange graph we drew, that doesn't have minimums or maximums on it. Okay, the range is the same thing as it was. It's -1 and below, 1 and above. So you could write the range if you want to, is you just say set of y is less than or equal to -1, or y is greater than or equal to 1. Or you could just do interval notation and say negative infinity to negative 1 with a bracket, union, bracket 1 infinity. Okay, so again, there's a gap between those U-shapes based on what the cosine is. All right, so that's the range. Okay, the period's 2 pi. All the rest of this stuff is the same. The amplitude, there is no amplitude on this one. Okay, and then the vertical asymptotes equation goes like this. It's k pi over 2. So we would say x equals k pi over 2. And we would say k is an odd integer. Okay, so that's how that's going to be put together like that. So the vertical asymptote equation is going to be different on both of these things because they're phase shifts of each other. Okay? Okay, so do you guys got any questions about what I just did with the basic graphs and how I put them together? Okay, so if you know how to do sine and cosine, you won't have too much trouble doing these. Now these are going to be a little harder, so these problems that I'm going to do now are going to be a little bit more advanced, but the big thing is, if you're doing a cosecant, the question is, can you do a sine graph or not? So we're going to end up sort of reviewing the sine graph and cosine graph and working on this more in depth as we do these problems, okay? So the first thing that you want to do, the first thing I'd like you to write down above your problem here is the general structure is y equals a cosecant, then have a bracket, then have bx minus c plus d. Okay, that's kind of the big structure of the sine, cosine, secant, and cosecant. Okay, and again on this one is, let's just kind of review, a is not an amplitude, so that's not equal to the amplitude on a cosecant, but it does stretch and shrink, so that is going to do a stretch and shrink. So a is really, it's just going to do like stretching and shrinking vertically is what that is. Okay, the period is going to be 2 pi over b. Okay, so that's so whatever the number in front of x is, you divide that, 2 pi divided by that, that gives you the period. C is the phase shift. And the last thing on that would be D is just up, down transformations like that. Okay, so that's as complicated as it's going to get. Is this particular problem right here has a stretch shrink, it has a period change, it has a phase shift. It doesn't have an up, down. So what we're going to do is we're going to identify everything first of all. Now the first thing you got to do, and this is real important, is this needs to be in a factored form. If it's not, then it's going to mess up your phase shift. So what we're going to do is anytime that you have a number in front of x, that needs to be factored out. Okay, so we got to write this in a factored form. So we write this like this. This is going to be y equals 2 cosecant, draw a bracket, take the 2 out, and then figure out how the factors go. Now this kind of thing right here always goes the same way. So you're going to have an x here, and what goes here, you're just going to take these two numbers and do this. What goes here is just 3 pi over 2 divided by the 2 you took out. There's no guesswork in doing that. It's just do this. That's going to be 3 pi over 2 times a half, so that's going to be 3 pi over 4. So what goes here is plus 3 pi over 4. Sometimes students struggle with that because they're not used to factoring fractions. You don't have to worry about it because that's what you're doing anyway. The other thing I recommend you do as a student is check this. So 2 times x is 2x. If you multiply that, that's 6 pi over 4, right? 6 pi over 4 reduces to 3 pi over 2. So you want to make sure that you factored it correctly, because if you didn't, your graph's going to be totally messed up. So make sure that you do that step correctly. Okay, so here's what we do then on this problem. To find the period, we do 2 pi divided by what number? Number in front of x. 2 pi divided by 2 is going to be pi. Okay, so that's what the period is. We do have a period change on this, just like the sine and cosines we worked on earlier in class. The amplitude, we don't have one. Okay, but the 2 that's in front of the cosecant is going to stretch and shrink, but it's not an amplitude. You don't have one on this. Okay, the phase shift is not 3 pi over 2. it's 3 pi over 4. So it's got to be in a factored form, and that's kind of the key thing, and that's going to phase shift to the left, so we're going to say negative 3 pi over 4 to the left. Sometimes these problems are going to be given in a factored form, sometimes they're not, so if it's not in a factored form, you need to do that, otherwise it'll mess your phase shift up. Okay, it won't mess anything else up, but it'll mess that up. Okay, yes?
So the phase shift, obviously, because the original function is x minus c on the interior.
Yep.
You're just asking what the phase shift is, but you do know from the actual finished function, after it's all factored in, it has to go left because it's plus.
Because it's a plus, right. Yeah. Yeah, and it's not 3 pi over 2 because you really got to take 3 pi over 2 divided by 2
right.
when you take that out, because you got to get that in a factored form. Okay. Now what we do to get the increment is we divide the period by 4. So the period is pi, and then we divide that by 4. So that means the x-axis is going to go by pi over 4. Okay. Anytime you have a period change, you got to figure out how to change those x values like this. So we're going to start at 0, and we're just going to count by pi over 4. So we got pi over 4, 2 pi over 4, 3 pi over 4. Now that's significant because that's your phase shift. Then we can go 4 pi over 4, and you can go as far out with this as you want to. Okay? And then, of course, you just reduce fractions, so that would be pi over 2. That would just be pi like that. So that's how your x-axis is going to be counted, is by those numbers there. So take the period, divide it by 4. That will tell you how your x-axis needs to go. Okay? All right. So let's go to the next page, and we'll try to put this whole thing together now. Now, I'm going to take a screenshot of the factored form of the function, because we need to look at that. Okay, and we're going to try to put this together in a couple of steps, too, with this. Okay, so we're going to work on doing this graph right here. So go ahead, and let's go ahead and draw out a xy axis like that, and let's get this thing set up. Okay, so what we just found on the previous page, our increment was pi over 4, right? So what we want to do is we want to just go pi over 4, and then 2 pi over 4 is pi over 2, then 3 pi over 4, counting by the numerator, 4 pi over 4 is pi, 5 pi over 4, and then I'm going to go out to 6 pi over 4, which reduces to 3 pi over 2. Okay, so I do that. You can go as far out as you want to. What I usually want you to do is graph one period. I don't care where it starts, but if you have a phase shift, the best place to start is at the phase shift. So here's basically what we're going to do on this problem. We're going to graph in 2 stages. The first thing we're going to graph is we're going to graph, and I'm going to use like red. We're just going to graph y equals 2 sine of 2 times x plus 3 pi over 4. Okay, now again, your goal on this is you don't want to do so many steps on this that you make it so hard to read. The idea is if you do a sine, just remember a sine starts there, right? Now this one, where is that point going to go? It's going to go 3 pi over 4, this one. So that first point's going to go there. All right, what is that 2 going to do to your sine wave? It's going to stretch and shrink. Okay, now the sine does have an amplitude. The amplitude of the sine is 2. So what we want to do is we want to put this together like this. Let's go ahead and go to the left so we can get to the phase shift. So that's negative pi over 4, and then negative pi over 2. Then let's go out to negative 3 pi over 2 like this. And then the y-axis, let's go up at least, we've got to go past 2 if we're going to graph the cosecant. Okay? So watch how I get these points put together like this. So we're going to graph the sine. So it goes like this. The sine starts at 0, 0. Where does that point go? Remember, I say start at the phase shift. So move this point to there. Okay, so that's point number 1 on the sine. Okay, that's set. What's the second point on the sine? Goes to the high point, right? The high point is not going to be 1 because there's an amplitude of 2. Where does it go? Goes to 2. There you go. So if you got 2 points, you can tell where the rest of them go. So now from here, it's going to go back there to the x-axis. It's going to go now to its minimum like that. All right, and then that's good enough. That's all I want is 5 key points through one period like that. Now that's the graph of the sine. Okay, do you guys understand what I did okay there? All right. If you remember where a sine starts, you can handle a phase shift and an amplitude at the same time. Okay, now, we do have asymptotes on this. The asymptotes are going to occur at what we call the midpoints. And I want to clarify what I mean by a midpoint. A lot of times students are always thinking, okay, the asymptotes are where the sine is 0. Well, what if you moved everything up and down? Then don't think of it that way. Think of these midpoints. A midpoint is just halfway between the max and min. So if this whole thing got shifted up and down, the asymptotes are still in the same place. So you want to put your vertical asymptotes through those 3 points. Okay, so let's go ahead and do that. So you'll have a vertical asymptote there, and you'll have one at negative pi over 4. And then we'll have one at positive pi over 4 like that. So see, all of the work on this problem is really doing that. We graph the sine. Now the rest of this, hey, you just draw your shape. I'll pick a color like green or something like this. So the final answer is going to look like this. You just draw the U-shapes like this. Okay, and that is one cycle through that graph like that. That's what it looks like. Okay, all right, so if you can get the sine done okay, then once you locate the asymptotes, the rest of it you sketch. You don't need to do, that's a very accurate graph. That's good enough. Okay, okay. So now let's see if we can find an equation for the vertical asymptote. What I always recommend you do is just list out the vertical asymptotes and see if you see a pattern. Okay, so what we have is we have negative 3 pi, and I think I didn't put the denominator on that right. That should be negative 3 pi over 4. So we have negative 3 pi over 4. Then we had negative 1 pi over 4. Then we have positive 1 pi over 4. Do you see a pattern? What do you think would come after 1 pi over 4? 3 pi over 4, right. Then after 3 pi over 4, what would come next? 5 pi over 4, right? Okay, so the pattern is odd integer pi over 4. So what you're going to do is you write this like this, okay? The number in front is k pi over 4, okay? So what's happening is it's the number in front of pi that's changing, and that's an odd integer. So you have to say it's an odd integer. So you would say the equations of the vertical asymptotes are x equals k pi over 4, and you would have to say k is an odd integer. Okay, that's how that works out. Okay, sometimes that's one of the harder parts of learning how to work with secants and cosecants is what is the formula of the asymptotes. Just try to find a pattern. Most of the time you're going to find a pattern on that when you look at that. Okay, all right, so that's how that basically goes as you do that. Let's finish up here with doing a secant, and that's kind of where I wanted to get tonight, is just do the secant and cosecant part. And then we'll do the tangent and cotangent part for about 30 minutes next time. Okay, so let's go ahead and let's do this one. And with this one's got everything possible here, except it doesn't have a reflection. So again, we're going to put this in a factored form. So let's go ahead and get this in the factored form. So we have the 1/2, then we have secant, then I'm going to put a bracket, put a 2/3, and then a blank set of parentheses plus 2 like this. So what goes here is an x. Now here's the part that you want to make sure you pay attention to, is when you factor out the 2/3, you need to take the 3 pi over 2, and you need to divide it by the 2/3 you factored out. That will always tell you what goes right there, because that's a little bit difficult usually to do in your head. So that's 3 pi over 2, and then if you divide by 2/3, you're multiplying by the reciprocal, so that would be 9 pi over 4. So that's going to be a minus 9 pi over 4 is what you're going to have there. And again, you want to just kind of multiply that out in your head, check it and make sure it works out. That's actually 18 pi over 12 if you multiply that out, and then that reduces to 3 pi over 2. Okay, so that gives us that. Has everybody got that okay? I just always take this number divided by that number. Okay, and that'll help you to always factor that. Okay, now, okay, the formula for the period is 2 pi over b. b is the number in front of x. So that's the b right there. So you're going to do 2 pi divided by 2/3. Okay, if you divide by a fraction, you multiply by the reciprocal. So that's going to be 2 pi times 3/2. Okay, the 2's are going to cross out. So it looks like the period is 3 pi. Okay, so I just worked out 2 pi divided by 2/3 to get that answer. Okay, the amplitude is none. There is no amplitude on a secant. There is on a cosine, but not on a secant. Okay, the phase shift, look at the final factored product. What's the phase shift? 9 pi over 4. Good. So it's 9 pi over 4. Which way? To the right. Good. Okay, so we got that. Okay, so what we're going to go ahead and do is we're going to do the increment again. Okay, so we're going to take the period, which is 3 pi, and divide that by 4. So that tells us how we increment the x-axis. Okay, now we're going to start at 0, and we're just going to start counting by 3 pi over 4. And you count by the numerator, so it'd be 3 pi over 4, 6 pi over 4, 9 pi over 4. That 9 pi over 4 is significant because that's the phase shift. Okay, so I like to usually make these problems so that the phase shift falls on the increment, because otherwise it's a little bit more complicated to do. It comes better to do with a calculator, I think. So then it would be 12 pi over 4 and so forth. Now reduce this to 3 pi over 2, and then reduce that to 3 pi. Now what I want to show you on this too is the significance of 3 pi is that's the period. So if you count 1, 2, 3, 4, 5, so we made it to the end of the period. So that should always happen if you count out that increment like that. Okay. So now what we're going to do is we're going to go ahead and get together our graph then. So I'm going to take a snapshot of this thing real quick. Okay, so let's go ahead and let's put together our graph on this then. Okay, and let's see, with this thing we said, let's see, we're doing, I'm going to put the cosine on here so I can refer to that. So I'm just going to write this over to the side. So I'm doing y equals 1/2 cosine of 2/3 and then x minus 9 pi over 4 plus 2. Okay, let me zoom on this a little bit and let's go ahead and let's get the increment put together here. So on the x-axis, we're going to go 3 pi over 4, and then it was 3 pi over 2, and then it was 9 pi over 4, which is where our phase shift moves to, and then 3 pi like that. Okay, let's just kind of work with that and then see if we can figure it out from there. Okay, right, now let's see, with this one, what we want to have is the amplitude is 1/2. On the cosine, the amplitude is 1/2. And then the 2 is going to move everything up 2. So it would make a lot of sense to me to maybe make this go up to maybe to 3. And then maybe down to -3. And then I'm going to put like little halfway marks in between like that. So what we're going to do is see if we can put this together. Okay, now I'm going to do this in a couple of stages because this one has got so much going on in it. So what I usually like to tell students to do is just graph the inside part. Forget about the 1/2 and the +2 because those things affect y. So actually all you got to do to graph this thing is the cosine starts at 0, 1. So if you have a basic cosine, you start there. Now that is going to phase shift to 9 pi over 4. So that point right there is going to move there. Okay, now I'm going to just have you lightly put dots on here. So that point goes there, and then we're just following the cosine cycle. It's going to go like this, like this, like this, and so forth. Now I'm not going to connect the dots on this or anything. I'm just going to say, okay, that we've got the points on that inner part right there. Now the rest of this, you want to try to do this in your head. You're going to take the y values, like this y value here is 0. You take 1/2 times 0 plus 2. Okay, and I'll take a different color and move this up. So 1/2 times 0 plus 2 is 2. So this point right here moves all the way up like that. Okay, that's a point on the cosine. Okay, the next one has a y value of -1. So you do 1/2 times -1 plus 2. So that is 1.5. So that point right there is going to move to 1.5. Okay. The next point has a y value of 0. We already did that. Okay. If y is 0, 1/2 times 0 plus 2 is 2. So this point moves up like this. Okay. And then the last one here that's really important, that has a y value of 1. So 1/2 times 1 plus 2 is 2.5. So this point here is going to move up to 2.5. Then the next point after that's going to be back to 2. So that's what I'm going to have you dash in, is that right there. Okay? All right? So what we'll have from here then, that's the graph of the cosine. Now, the midpoints, the asymptotes are here. Okay? That would be the points that are not the maxes or the minimums. Okay? So what you want to do with your vertical asymptotes is you want to draw one that goes through 3 pi. Then you want to draw one that goes through 3 pi over 2. And then one that's going to go through 0 like this. Okay, and then the rest of it, you just go through like we've been doing. You just go through and sketch it, and then you got it. So you're going to end up having the U shape that goes down like that, and the U shape that goes up like that. Okay, so the whole key of this was getting that graph done. That's the key, all right? Now I'm going to have you do this formula. The asymptotes go like this, and then that'll finish this up here. So the vertical asymptote, you can always do this if the pattern's hard to see. So you can just say the first asymptote that you want to pick plus 1/2 the period times k, where k is an integer. This one is actually a hard pattern to see. It's 0, 3 pi over 2, and then it would be, what, 3 pi? I mean, you can find a pattern on it, but what I'm going to do is just do it this way this time. The first asymptote is 0, so I just do that. Then I do 1/2 the period. The period on this was 3 pi times k, with k being an integer. So that takes all the guesswork out of it. That would be one way to write that equation. And then, of course, you don't really need the 0, so you could write that as x equals, this part here would be 3 pi over 2k, and then k would be an integer. What I'm suggesting on this is you can use this formula if you, or you can just see if you see a pattern. Okay, but that formula right there always works, and I don't care which asymptote you pick. It doesn't matter. That's up to you. I just picked the smallest one I got. Okay? All right, so that'll wrap that up, and then the next time we'll